Hello and welcome to another Bevy video. We live in good times. 0.17 came out this week and it is strange, this update, because it's actually quite a small update in terms of like things they added compared to like the last two, but they are like massive things that they've added in terms of quality of life improvements. They feel like a lot more iterations on previous things that they've released, rather than like the previous few updates have been just like a scattershot of like title and then like a paragraph of like, we added this thing that like we didn't have before. Whereas this is a lot more of like, hey, we added this thing a few updates ago and we've taken your feedback, we've improved it mildly, like massively, and now we're going to use that. And a lot of stuff like just, there are some things like drop shadows and stuff like that. It's just improvements, but it's like they've added huge stuff. They've completely redone how events and observers work, and they've also added a UI library so that we can actually use like first-party widgets. But let's get into it. So the very first thing is that they're experimenting with ray tracing. So it's all experimental at the moment, and it's kind of a really cool improvement. But personally, I'm not a graphics person, or art person, more graphics. Like I really do enjoy graphics, but to me, ray tracing is one of those, like, I never really see the whole wow ray tracing, because when I play like a high quality game, the effort that goes into making normal rasterized lighting look like realistic lighting or stylized lighting, depending on what they're going for, is to the level of like, to me, there's no like wow. But I understand like the appeal of ray tracing though, because like if you're an artist, the like styles that you can achieve with ray tracing, or like the minimal effort for some things, or I think the best example is like the new Spider-Man game that came out a few years ago now, had issues where it's like they were like, hey, because we're ray tracing it, there's a whole bunch of shortcuts we couldn't take, because if you weren't looking at a pedestrian, they would T-pose, because, you know, save memory, don't compute animations. But because they were ray tracing, like you could see them T-posing in reflections. It was like that wasn't an issue before ray tracing. Like ray tracing is a huge step forward, but it's just something that like, it's great for people that want to use that technology. It's just hard to talk about like why it's an incredible piece of technology, but it's experimental. So if you want to turn it on, you can. So there's path tracing and there's also ray tracing. So the idea is that you can run a path trace which doesn't run in real time, but will render your scene like exactly what it's supposed to look like with lots of bounces and like no noise. And then you can run a ray trace and compare. So you can make like, what does my scene look like if I did perfect ray tracing? And then you can compare that to what's actually happening with like the optimizations. And I'm assuming like if you've got enough frame budget, it will fire more rays. Like I think the number of rays is probably proportional to the frame budget. So you can like see like optimizations you can make and compare like the improvement noise wise to what you're actually getting. Okay, now onto something really exciting, for me at least. I absolutely loved observers when I worked out how to use them. Like when they first came out, I think I skipped them on that version because I was like, I don't get it. But when I started using them for like UI, I was like, fuck, these are incredible and like so powerful. And obviously like I wasn't the only person, because like Bevy is going like, hey, like we're gonna like rewrite the whole API, because like they're really popular, but like they've crept beyond what they were intended to be, and like we need to rewrite stuff because it's getting out of control in terms of like we co-opted a different system and now it's just not working. So what they've decided to do is split the events that were before observers and the events that were observers themselves now, and they've changed that, and they're going, okay, the ones that came before, they're messages now. So if you store it and read it later, that's a message. If you use it as an event to fire off a trigger and observe like reaction, that's an event still. So they've gone and changed the event trait so that like it actually like makes sense for observers, rather than being a like hybrid of the two. So they have three big reasons on why they made these changes. So the first is that it's like a confusing name conflict, because events were ambiguous with whether they were for observers or would to be buffered. It wasn't possible to know by like reading the implementation, like without like, explicit documentation, how you were supposed to be using a specific event. So you knew it was an event, but you didn't know if it went into an observer or if it went into a buffer and was to be read later. So what they've done, they've removed that ambiguity by like making them two distinct types. The second reason is that the API wasn't static enough. And what they mean by this is that like you couldn't like use the compiler to check your work. Like it could not be static analyzed, because events needed to be able to work in both places. They had to have the functionality to work in either. And this allowed for things to be misused, because you couldn't like hard type stuff. And one of these big misuses is that it's possible to trigger an event that needed to target an entity without actually giving an entity to target. And like this didn't cause any issues as like a compiler level, because it was valid to trigger an event without an entity, but it was like, but not this event. So what they've done is with the re-implementation of the event system, they've made it so that if you specify that an event needs a target, you cannot fire the event without providing the target, and vice versa. If you specify that it cannot target something, you can't fire the event with the target, and this is done but basically by including the target as part of the type, so a field that has an entity that is targeting. And the API did too much work. So the third reason is just that it's just too much. Because events could be used anywhere, there was a lot of code that was like generated by the compiler and like, monomorphization and stuff like that just didn't need to happen. Because you could store it in a buffer as a resource, like at an asset kind of thing. And you could also fire a trigger and stuff. Like, there was a lot of like redundant code being generated and like unnecessary code for like, if you're not using it this way, the compiler still needed to check that it was still a valid use of it. So there's a lot of redundant stuff that they cut out because it was like the API. So really they split it into two separate APIs now to reduce the amount of work, because not only does splitting the API in half, like halve the amount of work, like if you're not actually using one or the other, it doesn't not just have to compile that one, it doesn't have to do like sort of the cross checks where the two APIs would touch each other. It was a lot more complicated to check, and Bevy had to do like runtime checks and stuff like that to make sure that the events were in the right place and observers were doing the right thing. So that's all gone now. So the re-architecture. So this is where they've changed the old event trait into a new trait. So before observers, like events didn't need like anything in it. It was just a marker trait. But then they needed to add the functionality to be able to like traverse and propagate types and stuff like that. So they add all this to the event trait. But now that they're like, hey, no, like, we're not doing that anymore. They've removed all the propagation because they've decided that like triggers by default don't propagate. That is a specific use case of a targeting trigger, and not all targeting triggers will propagate. Some will just target an entity, others will target an entity and all its ancestors. So what they've decided to do is that the event trait just has a type that implements trigger, and this allows you to specify like whether it's a global trigger, whether it's a targeting trigger, whether it's a propagating trigger. All that is specified by the type that the trigger has. So they basically just stripped it right down to the bare essentials. Back in 0.16, the way you would make an event to be used in Observer is you would declare a new struct and you would derive event on it. This would then, make it, just flag it as being able to be event. It would set the different types and stuff that were needed. Then to add an observer, you would say world.addObserver, and you would then say trigger and then your event. And so this would mean that we have access to this event whenever it's triggered inside this observer. In the new version, they've renamed trigger to on. So this is like a grammatical change that it reads nicer, that instead of saying trigger game over, you say on game over. Like it reads like your intent. So on this event. So they renamed trigger to on. And that's really the only difference between actually using an observer between now and then, because by default, the behavior will be the default behavior. So when you derive event now, instead of like implementing the propagation or that, it instead just implements the trigger as having a global trigger. So a global trigger just means that like it doesn't target anything. It's just the top level observer. It just watches for this event and does its thing without having a specific entity it targets. But obviously that would lose functionality of the previous implementation. Obviously we don't want to lose the ability to have observers that target a specific thing. So instead, what you can do is you can derive entity event instead. And so an entity event still just implements an event. Like it doesn't make any actual difference, except it will swap out the global trigger for an entity trigger. And the entity trigger will have a specific entity targeted, and that's how it functions. So before 0.17, you would target a specific entity by saying world.trigger_targets, and then you would pass in the event and then a list of all the targets that event should fire at. And this is where the issue came from, is that like if you called trigger click, it would work. Like there was no complaint, except it just wasn't targeting anything. Now, what they're doing is saying click, the event click has to contain the entity that it's targeting. And you can't pass in a click if it's not specifying the entity. Now, this could personally have some limitations in that it means you can no longer target like a whole group of entities with the same event, because each event must have a copy of the data, because each event targets the specific entity. But small trade-off. The default implementation for when you derive entity event is that it will target the field named entity, but you can specify an additional metadata tag of entity target to specify which actual field should be the target when you pass in a specific event. The big win here is we can, at compile time, make checks. So, for example, if we say world.addObserver, click, it will add an observer that doesn't have any targets, and it knows that this observer doesn't have any targets and is able to do that. So we can actually just add it. If we spawn an entity and then use the .observe, we have to pass in a type that can actually target something because we are targeting it. So this means that we can actually have a compile time error that says, like, hey, you're passing in a type of observer that cannot target something, so it cannot be a targeting observer. And it's all checked at compile time. It's such a elegant improvement on top. But as I mentioned before, they turned off the default propagation because, again, it's the start with the minimum, build on from there. So because a global trigger doesn't actually target anything, propagating as a default behavior doesn't make any sense, because the default behavior for an observer is that it doesn't actually target anything. So what are you going to propagate to? So instead, what you can do is when you derive entity event, you can do a meta tag of entity event propagate. This will, instead of making the trigger an entity trigger, it will be a propagate entity trigger. Propagate entity trigger expands the behavior of the entity trigger to propagate up a specified relationship. By default, it will propagate up the child of relationship, but you could make this propagate up any relationship type. So if you wanted to make your own custom chain of observers, you can. This gives you full access to the original propagate functionality. So for example, you can call .propagate false to stop the propagation up the chain. In 0.16's version of triggers, there was a entity that was being targeted and also the entity that was causing the event to be fired, or the original target. This allows you to get access to the original entity that was triggering the event. Now, with this modification of the actual type that we used to declare an observer from triggered to on, it means that Bevy needed to rename some of its old types simply for the way it reads when you have it on the screen. So they had the lifecycle events, which were you could have a trigger on add player, which would then trigger the observer anytime the player component was added to an entity. But because they've renamed it from trigger to on, they can remove that from the actual event name. So now the event is just called add. This means that the type declaration actually reads as on add player, which is exactly what it's doing, on add player. So it's just a rename, but it really does cohesively hold everything together. You can really see why they renamed it from trigger to on. Is it just, when you read it, it makes sense what it's doing. Entity event lifecycles also have their own custom trigger, the entity component trigger. This allows for very specific interactions and can be more efficient and optimized compared to the previous way that Bevy was doing this, since it allows them to pre-allocate certain pieces of information rather than having to clone everything everywhere. It's also possible to make your own trigger type. Basically, as long as you implement the trigger type, you can come up with your own logic about how an event should be triggered. This allows for observers to be incredibly flexible without necessarily adding a lot of bloat to Bevy. They do note, however, that it should be unnecessary to build your own triggers at the moment, but this is primarily because all the functionality that previously existed with Bevy's observers is being replicated with the currently existing triggers. But by giving us the functionality to create our own, they are allowing for the potential for the community to come up with new types of observers that Bevy may, in future updates, add back in. The final section just covers events versus messages. So in previous versions of Bevy, the event trait was used for both observers and for buffered events. This means that it was confusing, as both had their own sort of way of doing different things, but could both kind of seen as events. But it was decided that this should be split apart because even though they're both technically events by name, their functionality was different enough that they were starting to bloat the other. So instead, they've changed it to now, an event is used when it is triggered, whereas a message is used when it's buffered. This means if you read and write it into storage, then it's a message. Otherwise, it's an event that triggers an observer. It's still possible to use it as both a message and an event. It just requires driving both traits rather than being able to just use it as both without any consideration. Next is a feature that I'm super excited for because I've been working with someone on the Bevy Granite editor, and we've been having issues with EGUI in terms of performance. I think we've fixed a lot of those, but the fact that Bevy now has built-in widgets for building tools is incredible because it means that I'm going to just strip EGUI out because I don't like using the extra context of having to define everything in EGUI and then pull stuff out of Bevy, put it in EGUI so we can render it to the user. This gives us the ability to just make that functionality, not completely there because I don't think they've got text editor fields and stuff like that, but the ability to use widgets as Bevy's got these built-in tools is going to be incredible. So they're called Bevy Feathers because, like, after my own heart, they name things with puns or like related topics. So Bevy being like a flock of birds, the feathers are the dev tools or the dev widgets, and it's just beautiful name. Oh, just magnificent. So there's not really much to talk about in this section in terms of like I did through the observer section, because there's like a lot. The observer's incredible improvements, but feathers is just more like they added widgets. So they will explain like what they've actually, like, why they're doing this. So the idea is that we want to have like unified dev tools. So if you go and build a plugin that gives you access to some kind of editor or dev tools related stuff, you want it to look the same when they add like a different plugin that also adds something else, but it's not related to your credit. So with EGUI that kind of works because like everyone's using EGUI, so the EGUI can all like share a context and tie together. So what this is doing is it's saying like, hey, here's the Bevy like context tied together, and now because it's built into Bevy, we can be like, hey, here's the style resource. So if you want to use the feathers, you just use them, and then if the person who's doing the development goes, oh, I don't like the way that it looks, or like I need a different color because of the colorblind, they can tweak the style and it'll change all the plugins. The third-party plugins that have no knowledge of the other third-party plugins, they'll all be updated to use the same style and layout and stuff like that. So it's like a unified dev tool building kit. So the idea, I think, with this is that they're releasing it to us now so that we can find all the issues with it and they can then use it in the editor later. And it's more useful like to have like, here's a dev tools that like they won't fit the theme of your game and they'll be hard to overwrite, that kind of thing. Well, being like, they're not designed to make them feel like they belong. They're designed to let people build tools that feel like they fit together. Like there's a tool set expansion, I guess. So what they're currently available with Feathers is, so the standard widgets designed to match and look like, feel like they belong in the Bevy editor. So again, like when they do release the Bevy editor, it means that like a third-party plugin will look like it belongs in the editor. It won't stick out. So it's similar to how Unity, you can define and just clear like bits of the editor, but it doesn't look like the same as the UI in the game. It's the editor and UI are two separate like layers. So there's the essential like elements. So there's a button, there's a slider, there's a checkbox, and there's a menu buttons. When they say menu, they mean radio buttons. So like that's this one here. So you can click 1, 2, or 3, and like depending on which one you click, will you only click one, where as opposed to a checkbox, where so you can it's either checked or unchecked. Radio buttons are like it's this value out of a set of values, and there's also like a disabled and enabled thing. It's cool. So layout containers. So this is like the idea of like you can have a horizontal and a vertical and a grid, and they're like basically the same as the UI in normal like Bevy layouts. Or normal Bevy UI, so it's just like a sequence of like you can specify how things are laid out. Accessibility features, this is like one of those why it's amazing for Bevy to have first-party support and not third-party stuff. Third-party stuff always just gets what's bare minimum. This is like, no, Bevy wants accessibility stuff, so they'll have built-in screen reader and other accessibility tools. There's an on-screen keyboard and stuff like that. So it's amazing. Headless widgets. These are going to be like Love the fact that like they built the groundwork and they released Feathers at the same time. It would have been kind of annoying, but also understandable if they'd released the headless widgets, then Feathers, and then the editor of like 3 layers of building on top of things. And that would have been quite clever because it would mean that they can refine the headless API, then release Feathers with the improved API. But I'm so glad that they gave us Feathers. It's probably also because like Feathers was really easy to do on top once you had this base foundation. So the idea is that you just have like a structured thing of like systems and events and triggers and observers and all that all set up like types or defined so that like you can just build your visuals on top without having to worry about how it functions. So the idea is that like a button will emit an active event when clicked, an activation event when clicked. A slider lets you edit an F32 value in a given range, so you can specify what the minimum and the maximum is, and then when the slider moves, it'll fire an event that represents that value between the minimum and the maximum based on like how far it went. Like a scroll bar, I'm assuming is the same, but like lets you click horizontally instead of vertically. I'm not entirely sure what a scroll bar, because it says like lets you scroll through the contents of a UI, like or a UI node, but I can't see why that's any different to having a slider and then making that slider. Maybe you can use the mouse. I'm not sure, because they didn't really show it up. But yeah, I don't know what the difference between a slider and a scroll bar is. Maybe again using mouse wheel or something like that. Checkboxes, which will trigger a a state change. So whereas a button will emit I was clicked, a checkbox will emit I am now checked or I am now not checked. And then radio buttons or radio groups, which let you select an item. So I'm assuming it'll fire an event saying like maybe the index and the name, or just the name, or like however it wants to, but it'll fire an event when you select one. It'll probably fire like a selected and a deselected event in that, or like in the order of deselect this one, now select this one, that kind of stuff. It's all, again, like it's functionality that makes it easier for you, or like for developers to build tools for other people to then build on top of. So there's hot patching system. So this is another one of those like incredible improvement that like everyone's been going, oh, it's not, you know, this, it's like, and they added it. Like, I don't know if it's been a long time coming or whether it's like some crate released it, someone made a plugin, and then they're like, oh shit, we've got to put this in, because like almost every like complaint on my video about like, oh, you know, Bevy's not hot reloading, it's not really hot reloading. Like people are like, oh, but you know, you can't change this in, like Rust takes too long to compile. It's like, well, that's fixed, because you can like literally, it will recompile a system at runtime and stick it in while the game is running. You don't need to recompile, don't have to rerun things. So what this does is that, like, I'm assuming, like, if you just enable the feature, I think this cargo feature hot patching is enabled, that every system can now be modified during execution, and the changes will immediately be visible in game. Immediately, not necessarily true, because it still does need to recompile it, I assume. So if it's taking 30 seconds to recompile, like, it's still going to recompile. But the idea is that you don't have to recompile and relaunch the game. You can modify how a system works. So, for example, if you have a constant for the speed of the player, you can modify that constant in the source code while still in the game moving around, and it will update. So the idea is that it will like recompile and then patch the binary while it's running to have the hotfix work, and that is awesome. So what they're saying is at the moment it only works in binary crates. So if you modify a dependency, the dependency won't be updated, but the crate itself. So it only works in binary crates. So not supported in WASM, and so this is saying that like it works in terms of the underlying crate that they're using. It just doesn't work because Bevy doesn't interact with WASM in the way it would need to. So next update, that'll almost certainly work, because it's just a Bevy needs to do something first. And they probably added this quite late into the cycle, I'm assuming. So if the system's parameters change, it will not be hot reloaded. So again, its work needs to be done on Bevy's side, not that this is impossible. It's just that Bevy, under the hood, I think when you add a system, builds up like a metadata field that tells it like the information that needs to be passed to run this system. So like how to lay out the memory that you pass to the system. And if you modify the parameters, you can't hot reload it now, because you've told it that it takes 2 ints, and you've modified it that it's now going to take 2 floats. It's like, well, you can't do that, because it's still going to be passed to 2 ints, because that's how the code's set up. You can change what it does with the 2 ints, but you can't change the fact that it's given 2 ints. And it's because Bevy builds that when you add the system, and so there's no way to, while the system is running, modify that underlying functionality. Bevy can add that functionality, they just haven't for this update. So no modifying what resources your system needs, but you can modify what it does with those resources, which is incredible. So then the deep learning super sampling, this is personally not that interesting, in that like they keep adding anti-aliasing methods, and it's like, okay, cool. Like to me, it's coming back to the, I'm not an artist, so my artistic intent isn't there. So like the different types of anti-aliasing don't mean anything to me, because they all modify how something looks and feels in a way that I personally don't care about. Some anti-aliasing, I actually rather the jagged edges. I don't like anti-aliasing ever, but it's a me thing. But it's what this is it's if you have an NVIDIA graphics card, you can dedicate, they've got like built-in AI chip accelerators that they use AI to anti-alias, like it's deep learning super sampling. So the idea is that like they train an AI to be able to anti-alias, and there's dedicated hardware on NVIDIA chips to do this. So compared to built-in, so the TAA, so TAA was time anti-aliasing versus this deep learning is that so produces higher quality, more stable images, because obviously with the time-based approach, because you're layering previous frames, as things move, they will get motion blur, because like the previous frames worth of information is still there. At least I think that's how the time-based one works. I don't actually know how they calculate the time. Like I assume they don't keep a buffer of all the previous frames to anti-alias across. It's like it keeps blending in. So like if something's moving, it gets a shadow because it's in 2 places in 2 different frames, but it bleeds out really quickly. But yeah, so it's more stable because it's using an AI that's generating the image, rather than like time and the average of time. So it also supports upscaling, so you can go from 1080p to 4K, and it'll smooth the edges because it's like AI. It's cheaper to render because it's like dedicated hardware. But it does require an NVIDIA specific graphics card, and then currently requires running the Vulkan backend. So no Mac, no web, no DirectX, and not mobile support. So then we got TileMap chunk rendering. So this is like another one of those weird things where they've added one functionality of what will become a complete feature set. So in this, they basically just added the ability so you can specify a tile map chunk, the tile set that chunk pulls from, the size of that chunk, and then the actual the size of each tile when it's rendered, and then you pass in tile map data and specify basically the index into the tile set that each of the tiles is, and it'll render a chunk as one mesh, or and not mesh because it's 2D, but like one sprite will render rather than having to have an individual entity for every single sprite. Raymarsh atmosphere and space views. Again, this is another one of those like really cool that Bevy has as a baseline thing, and it's all developed by volunteers, so it's not like, oh, why are they adding this feature that like they could have added other stuff with this time. It's like some person really liked this, so they did it. So Bevy's had for a while atmospheric lookup. So the idea was that you could like specify a bunch of parameters and it would generate like a dynamic skybox that like you could move the sun around, and it would actually like move the sun and like render at sunsets and sunrises and stuff like that. And now they're doing it with ray marching. So they're saying like flight sims and planet scene from space, cinematic shots, like more realistic, looks cooler. Whereas you can like use the lookup table version or lookup texture to do it if you want to do it like big open spaces and stuff like that, or long distances. So it's faster but less accurate. So I think the lookups what they had, they've added ray tracing. It's kind of cool. All you do is change like one parameter in it. Specify stuff. Procedural sun disk. So this is the same as like how the procedural atmosphere is like it renders what the sky would look like in sunset and sunrise. You can now also specify like the size of the sun, the angle, the intensity. So I believe the angular size is how big the sun is in the sky. So basically it's like from here to here is 90 degrees, and then the sun is 3 degrees. Like that's the size of the sun. It's how percentage of the field of view does it take up. It's the angular size, and then like intensity is obviously how bright the sun is. Yeah, so the idea is that like you could make the sun just sort of just go above the horizon, or you could go all the way up across the middle of the sky and back. Like you can specify that sort of parameter stuff. So you can have like a dynamic sun. Kind of cool. Again, like it's great for, you can just throw these in and have like a really cool looking scene without having to like code and all this stuff. Another thing that I'm kind of like looking forward to, because I think it'd actually be kind of cool, but like I haven't worked out what project I'm going to make. I just want to do something with this because it's kind of really awesome. Is web assets. So the idea is that instead of having to like have all the assets in a folder, you can just be like, yeah, just load HTTPS example.png, and it will go on the web. It'll download and load it. There's this little feature you can enable called web asset caching, which is that at the moment it'll just by default. At the moment, it's already a feature. By default, it will download, like decompress and load the asset normally. If you have web caching on, it'll download and save into like a temporary file, so that the next time they launch the game, it's already downloaded like that. Whereas if you don't have this enabled, I'm assuming when you close the game and reopen it, it's like, well, it's going to unload. Or if the asset unloads for some reason and you go to load it again, it'll be gone. So really cool feature. And we will see what people do with this, because like I've got some ideas for like multiplayer games, that kind of thing, of like you can now make it so that people can like upload user content and you can download it from your website, because you can interact with that kind of stuff, and that's fucking awesome. So another cool thing, because I'm currently working again with an editor, and I'm trying to make a reflect-based scene saving and loading, so that you don't have to like derive, serialize and deserialize on everything, because with reflect you can actually like reconstruct all of the stuff without actually needing to know any of that stuff. So auto reflect registration is basically, if you derive reflect, it will automatically be registered. You used to have to call app.register type and then your type. You can also say don't reflect, like don't automatically reflect type. When you derive reflect, you can then like add the metadata reflect, no auto register, to make types if you didn't want them to be registered. Not entirely sure where you would use that, but I'm assuming there's certain types that might be the case, like I just vec, where it's like you don't want it to automatically register because automatically registering might register something else. But again, it's interesting. But you can still register generic types, just not automatically. Frame time graph, again, another one of those things I'm kind of really excited for, just because I'm making it, specifically I'm making an editor, like it's something I personally resonate with. So it's just like the graph that's like, hey, this is how long the last so many frames took. So it's not rendering FPS, it's rendering frame time. The idea is that a higher bar is worse because it's taking longer per frame. And I think the color is like red is taking too long, green is within acceptable time, and it interpolates the color in between. So the idea is, I guess, if you would drop below 60 FPS, it'd be a red bar at the top, and if you would go above 120 FPS, it's a green bar at the bottom, and then in between. Kind of cool. Again, it's a very, very small thing, but it's nice to have this built in instead of having to do it yourself. So there's Bevy Dev tools and you can do it. Kind of cool. And it's getting to some of the smaller changes, like little tweaks that I was talking about earlier, where it's like they're not massive changes or improvements, but they're just still like small things. And there's a few of them in this update, just like there was some bangers at the beginning. So 2D text drop shadows. So they're saying that the UI 2D text had, or I guess just text at that point, had drop shadows. But in 0.17 now, the 2D text also has drop shadows, so you can do like in-world tooltips and have like drop shadows and stuff like that. It's text background colors. They've added the ability to specify a background color, and that just fills it in. And they also added that to 2D as well. So it's lovely. So words-based tooltips. Yeah, it's just sort of like a little quality of life things for text. UI gradients, and self-explanatory, I guess. So the idea is that you can specify a background gradient and provide gradient rules to do gradients, and you can also specify a border gradient, so the borders can have different gradients to the actual internal shape. There's like 3 different types of gradient: linear, conic, and radial. So linear, I'm assuming, is like left to right, like this is linear. Yeah, so this is, that'd be linear. Then that would be conical, I would assume, and then this would be radial. So as you go out, color gradient, go across, color gradient, and this one's like as you go round, color gradient. So kind of cool. Defaults to OKLab as the color, which is just, I think, a very good color space to do a lot of stuff, because like there's a per side UI border colors, so instead of having to just have a border color, you can now specify like the north, or the top, the bottom, the left, the right can have different colors. And apparently this was used by CSS to do like to give buttons depth without actually having to make buttons have depth, which is kind of cool. And so they just added this functionality, just again small little tweaks for people that are doing that kind of stuff. So there's a specialized UI transform, which is an interesting direction. Like it's a direction I think Bevy should have started with, but it's something like so with like game engines, there's what they call like true 3D and pseudo 3D game engines, or like I guess it's true 3D and true 2D, and then like hybrid approaches. So something like Unity takes the hybrid approach where all transforms, and Bevy did this too, all transforms have XYZ. And the idea is that even if you're making a 2D game, you still have XYZ. Z just represents something else. So like in the case of 2D, Z is layering. Whereas something like Godot has 2 different engines. It has a 3D, which has an XYZ, and it has a 2D, which has an XY. Like they are distinctly different transforms, whether you're in a 3D world or a 2D world. Whereas Unity and Bevy is like, no, the same transform regardless. So Bevy did the same thing where UI was UI, and regardless, like it still used the same transform, but they've pivoted to the other direction now. They're going, hey, 2D, 3D, you have the same transform, but UI has its own transform, because in 2D it still acts like 3D. Like it's the same thing, but you just have depth. Whereas UI is laid out using like a grid and flexbox and all that. So the UI actually acts completely different. So now it has its own transform, and they're saying that this is great because it cuts down on redundant work. It means that like you don't have unnecessary calculations of updating the hierarchy with the transforms to then recalculate where everything's going to be based on the UI layout. Instead, UI transform is completely own system, completely independent of the actual UI itself, and specialized to like, so they can make it much more efficient about mapping it out to space and keeping everything nice and worked out. Cool improvement. Again, is one of those things you're not really going to notice, except you may have to tweak some like things, because you'll have to actually use a UI transform instead of just a regular transform. I'm also excited because I do remember I was making one game where I was being silly with it, and I was using the transform like the same object for the UI and the actual object in the game, like they were the same component, or the same entity, and that didn't work very well because obviously as soon as you put it into the UI, Bevy starts controlling its transform, and that means that you can't move it around in the game anymore because you no longer have control of the transform. This would mean that you can do that because you could literally like have the image handle on the same entity and a UI transform telling you where to render it as a UI element, and a transform telling you where to render it as a sprite, as two separate things. So the same entity can be represented in the UI and visually rendered in the game at two different places, while still being the same entity. So I personally have had experience where I'm like, this would have actually been really cool, is to have like a specify somewhere else, like specify a UI position and a world position. So again, awesome. So data-driven materials. This feels like they've been watching my live streams because I've been trying to learn shaders, and this bit here has been pissing me off. So what they're saying is that like the material way of doing it, like where you derive a trait, is really type safe, really, really powerful, like for doing specific niche things with shaders and making sure that you don't absolutely fuck up and like pass the wrong data around. But it's needlessly restrictive. It's also specialized from 2D and 3D. There's no way to make improvements to 3D that don't just have to be copied to 2D. Like you can't make it like universally apply. Changes to 3D need to manually be done to 2D, even though they're mostly just copy and paste. So what they've done is they've said, hey, it doesn't need material anymore. Instead, there's a bunch of like weird like stuff that when you derive material now, or as bind group, it can do a bunch of, like, it does a bunch of weird stuff that when you then use it as a material, it can fetch that information. But that means that you can actually at runtime, or like just manually code, like it's a new manual material here, you can manually code in all the information and behavior of being a material, which is what they're doing here. So they're manually declaring a shader material without actually having to implement material. And it means that like you can make the materials more flexible, because instead of it being a material or a 2D material, you can just be like, hey, this is how I'm declaring stuff, and then you take the stuff that you need if you're either rendering in 2D or rendering in 3D without actually having to modify the underlying bind group stuff and all that fancy shader related things. And so to me this is really great, because it means that I can like probably go back, if I do go back to my shader stuff, and use a lot of Bevy's built-in shader stuff rather than having to do what I was doing, which was like work out how the hell to declare stuff. Because like this manual implementation, like they've got like a resource that you can be like, hey, like assign me a bind group now, and then like from there everything works. Whereas before it's like you had to then like store the bind group somewhere and interact with it. Maybe you could have done all of this stuff before. I was teaching myself how to do shaders, but it was not very intuitive. Whereas this feels like you can do a lot more, because they've removed a restriction of you have to derive this type, and deriving this type will then do a bunch of other stuff. Now it's like, hey, like deriving this type will implement these things, or you can just do it manually. And they're one of the big powers they're saying, so utilizing 2D and 3D improvements. So basically, if they improve the 3D, which is where a lot of the focus is at the moment, the 2D automatically gets it if it's applicable. There may obviously be additional optimizations, like they're saying, like they will optimize for 2D in the 2D case. But like if they improve the general rendering so it's faster, in the old version, if they did that for 3D, the 2D didn't get anything. Like they make rendering in 3D faster, nothing happens to 2D. Now it's like if they improve rendering in 3D, if the rendering is generic to all rendering, 2D automatically gets it. So that's the idea, is that like you can optimize for 2D, but like any improvements to general rendering automatically gets to 2D. So exploring new material representations. So this means that like the type safety of deriving material means that you can't modify a material at runtime dynamically. Like I think you could, like if you were doing like I was doing like a manual shader, like you could define some kind of type that then was able to define other types. Maybe not though, because boy was shaders difficult to keep type safe, because you had to like define the different types that your different types would then convert into the shader. So that's what they're saying. Having it this way means that you can at runtime modify like the parameters that a shader material would take, whereas when you derive material on a type, you can't modify the fields of that type, whereas now you can. And then modularizing the more mid-level APIs, so that instead of like having to do what I was doing, which was I didn't want to use Bevy's high level API. I had to go all the way to the bottom and work my way, like, and build my own low level stuff to make the interactions. They're saying like they can make the more middling layers, where it's like you don't want to use the high level stuff, then you can interact with like the middle level layer to build up a higher level abstraction instead of having to go all the way to the bottom, build the middle and then the top. So they can make a lot of the improvements like interact more nicely. So it's gonna be cool. Another like just sort of general improvement to certain APIs that we won't necessarily see is as spawn ticks. So at the moment, Bevy, or in previous versions, because again now it's added, Bevy has change ticks, which is the idea of like when was the component added, when was the component last modified, and you can use this to do all sorts of interactions with the ECS to like find out when changes are made and when modifications happen, and her behavior. But you had no way of knowing like if the entity has just spawned or whether they just added a component. There was no way of distinguishing between this entity just spawned in and has these components, or this entity existed and they added this component. So entity spawn ticks is that. It's a way for an entity. Confusingly here, I don't know how it is spawned as a thing, but anyway, the idea here is that there is now a component stored on top of the entity that lets you access the spawn details of that specific entity and know information about it, like the ticket was spawned in, and so now you can know, did it spawn this turn or did it spawn a previous turn. So they're also using spawn details, spawn by. So if you have location tracking turned on, you can also like know exactly what line of code spawned this entity in. And they're saying don't do this in generic normal code. It's for debugging purposes, really slow. Basically it saves like the exact line that any entity spawned on, so that you can print out like who's spawning these entities, where is it coming from. Pretty cool. And then there's obviously like a spawned filter, which means that like it will only have entities that were spawned since the last time this ran. And there's saying that this isn't an archetypal filter, which means that it does have a I think it's an n of n runtime. So the more entities match the archetype, the more entities it has to check, because it checks every single entity to see if it was spawned before this is like since this system ran last, and same with added and changed. Whereas archetypal ones is basically like it can just say, hey, none of these could possibly match. Whereas this one, it has to individually check. So they're saying the spawn filter is the same as grabbing the spawn details and checking individually. I think it's slightly faster, but like it's effectively doing the same thing. It's just checking button inputs for keys. So it's an interesting change. This was like a weird thing where like a few versions back, Bevy changed what key codes meant to what keys meant, and now they're saying, hey, like we added the ability to go back to using keys if you want that functionality, because they basically stripped it out. So the way key codes used to work is it would say like key F, and it was when they pressed the F key on their keyboard. So if they remapped their keyboard, or if they had a non-English keyboard or whatever, the F key was a different key. Like it meant like, the actual key when you press this that would render F, like would write the F down, that was the key code F. But they changed that to being on a standard QWERTY keyboard for America, where the physical F key is, that's the key code key F. And key is what key codes used to be, where it's actually the character F. So when you click the character F, they do state that like you're unlikely to need this, like just use key codes, because the key codes is like WASD. The key codes WASD means if they're on a French keyboard, which has different keys in those locations, they still work. Like it's the physical key location, whereas the key is like whatever's bound to here. So saying there's certain things that it makes sense, like plus and minus, where it's like, because you don't want them to have to press the specific key, you want them to press the key that's bound to plus and minus use key. But most of the time you're actually thinking more like this is a good physical layout, so you don't want their keyboard bindings to be what fucks you up. The other thing being, like if you were having like a game that could be rebind keys, you want them to rebind like by pressing the key. You don't want them to be like, oh, I've changed my keyboard layout and now the keys are wrong. So key codes make most sense, but key is like an alternative to like if you were like, hey, press this specific letter, not press the location on your keyboard that is that. This is Val helpers. This is kind of boring, to be honest. It's just like Bevy does this occasionally, where they add a bunch of functionality like .default that it's built into Rust, in that you can call like capital D default. So colon default, and that will insert the default value for the rest of it. And Bevy went, as so repetitive, so much we have to do it. Let's just make the ability to say it like all lowercase default, and it works. And so that's the same thing they've done here. Is you can just say pix percent, horizontal, vertical, like constructors for building the val type, which is the UI representation of stuff. So like the pix means like actual pixels, percentage is percentage of parent. So if you said like width is 50%, then the UI element will take up 50% of the parent space. And then there's viewport height, viewport width, the minimum between, like the Vmax is the minimum between the height and width, and maximum between height and width. So this one specifically the width, this is the minimum of either the height or the width. So if they have a non 916 monitor, like if it's not rectangular, which one is the minimum and which one is the maximum will vary. So you can take whichever's bigger. The idea is that it's just a bunch of constructors that let you easier to make these layouts. And I will probably never use them. They're good for people that do. Yeah, not much to say. There's a GLTF forward semantics configuration. So the idea is that Bevy uses the right hand rule, I want to say. Might be the left hand, I don't remember. But basically in Bevy, Z is forward, Y is up is positive, and Y, right is positive in the X. So negative Z is forward, and in GLTF, that's not the case. In GLTF, that's the case for the camera and for lights, but it's not the case for models, which means if you render a model, export it in GLTF, and load it into Bevy, it'll be facing backwards. I think Bevy, because again, they do mention that it's a weird thing about configuration, basically. So the idea is that if you spawn a model in, Bevy knows that the model is different. Like the coordinate space that the model is built in is different to the coordinate space Bevy uses. So when you spawn a model in, the Z's the wrong direction and the X is the wrong direction. I like that. That's flipped. So it'll just turn the model 180 degrees, because that would set the X right and the Z right, because now the Z is negative and the X is positive. So rotate 180 degrees around Y. And Bevy does this automatically, so that when you render a GLTF scene, it looks exactly the same in Bevy as it does in GLTF, or from wherever you export it from. The issue is if you then go, hey, transform forward, it's backwards, because the model is actually turned 180 degrees so that it looks like it's facing forward, but it's actually backwards. And so Bevy's just said, well, you can configure that. You can say, hey, use model forward, which means that you can do it globally or on when you're loading a very specific, like an individual model. But the idea is that if you say, hey, model forward, it means that the camera will be the one that actually gets flipped around, and the rest of the scene will render so that the model is pointing forward. So it'll modify the actual coordinates when generating the mesh, or when loading the mesh, so that the forward of the model is the forward of the in the world, rather than making the model and then turning 180 degrees. So that's what that does. But they do say that when you do this, it will in fact it'll make the cameras point the wrong way, but Bevy will intentionally, so when you spawn it in, it'll look the same. It's just that now your camera will actually be facing backwards in terms of when you spawn other stuff in, manually, the positions will be different because the camera is actually pointing the other way. So now we've got a render startup schedule. So in rendering, again, been doing shaders, there's a whole bunch of stuff that's not initialized until after the game runs. I assume that's what Finish does. So the idea would be that when you set up all your plugins, there's a certain amount of stuff that can be done while the app's setting up, and then there's certain stuff that can only be done after the startup systems will run. And so from what I understand, the finish is that the startup systems will run, the finished of all the plugins will run, and then the main update loop will run. I think that's how that works, at least from what I understand of having read this bit. So what this meant is that if you wanted to do certain things with rendering, you had to do it in finished, because you needed the render, the render device, which is the struct that lets you talk to the GPU. That needed to be initialized, and that doesn't get initialized until after the app runs after it runs all startup or something. So you put it in finished so that you can interact with the render device. And so what Bevy's done is they're going, oh, okay, that's ridiculous, because it's such a pain in the ass to do this. So instead, they're going to be hey, we've got a render startup. So anything that needs to interact with stuff that would otherwise need to be finished can go into render startup. And so we'll run the normal startup and then we'll run the render startup so that you don't have to worry about the ordering. It does cause some weird stuff. So in this particular case, we have our from world implementation, and then we, in our finished, init our resource. Whereas they're saying, hey, flip this around now. Instead of implementing from world, you instead make a system that inserts the resource, and then you put that system in render startup. So that means that startup will run and render startup will run after startup. So it moves where things are, and it just makes it more intuitive to be like, hey, you can do everything in build now. You don't have to like be like, I've got to make sure that this piece is done after that piece because it needs to go into finish. So it's just about making it more convenient to be able, like, stack everything. And it also, like, as they point out, means that the scheduler gets to be involved, which means that you can have a whole bunch of different plugins stick things in to the schedule, and then it runs and the scheduler works out the best order to run everything in parallel, like absolute maximum parallelization. Whereas putting everything in finished, each plugin is added one at a time. So no matter what, you're running linear, like on a single core, all the stuff's inserted. But with the scheduler, it can run massively parallel. So every core gets used. So it's just faster setup. It's kind of cool, but, you know, weird. So component propagation, which is an interesting thing. I didn't realize this is something that like people would actually need, but it makes a lot of sense. So the idea is that sometimes you want to be able to insert a component on something and have that component like apply its value to all the components below it, or like all that kind of thing. All its parents up the root. So like the idea of like, it says background color, and it's like, well, all of the parents get the same background color, something like that. Or the font's the example I'm going to use. So the idea is that like setting the font will propagate the font through the hierarchy. I don't know if it goes up or down the hierarchy. That was unclear, but the idea is that they've added a hierarchy propagation plugin, and that takes in 3 parameters: the component that you want to propagate, the query filter that's used to like specifically only propagate this to certain components, so it doesn't necessarily have to go all the way down the tree or to every single child, that kind of thing. And then you can specify the relationship. So in this case, it uses child of, so it's just propagating the relationship normally. And then there's also a couple of like different components that you can insert. So there's the propagate, means that I assume this takes in a copy of C, and the idea is that when you say, hey, propagate, it will then add that component with that value to all the children. There's propagate stop, which means that like while it's propagating, if it hits propagate stop, that's it. Like it doesn't continue down that branch any further. And then there's propagate over, which is like, instead of stopping propagating, it just skips that one and goes to the, like, you know, so if it's going down and it hits a child that has propagate over, it'll then go to that one's children, and rather than stop just means don't keep going down this line. Like over just means skip this one. So useful. As they're saying, like, they're like, oh, no, don't click that. They're saying like it's a very general tool, so like let them know so that they can add examples to the documentation about like, where you would use this, because it's a powerful tool, but like it's hard to come up with concrete examples because it's a very generic, like, you'll need this, but we don't exactly know when. It's like here's the thing that's synchronizing colors and alpha values of ghosted values, ensuring all parts of a model are on the same layer, and propagating fonts. So the idea would be like, if you wanted all the font from on a UI to be the same, you could just set the font at the top and that will propagate to all the lower layers, rather than having to specify the font on every single thing that has a text value. Infinite children. So previously in the children's macro that you used to spawn in children when spawning a entity in, they had a hard limit of 12, and it was just an arbitrary limit. It was just like when you derive a macro like that, or like when you create a macro like that, you specify like, sometimes I think Bevy like uses another macro to make the 12 macros, but the idea is that you have a macro that's like 1 value, and a macro that's 2 values, a macro that's 3 values, a macro that's 4. So you have 12 versions of the implementation, or 12 versions of the macro, and you stop at 12 because 12 is the limit. Like that's where you just arbitrarily said that's enough. And apparently there's some workarounds. Rust eventually will support like an ability to do this as like part of the actual compiler, but they don't have that yet, and who knows when they'll have that. So there's some workarounds you can do to be able to remove this limit, and I'm assuming it's like a macro that writes itself. But the idea is that Bevy didn't want to do this workaround when they first added this, but later on they found out they're like 12 is actually a low enough limit that people manually hit that. So they implemented the workarounds. And with implementing those workarounds, the limit is now 1400, and that's because that's a limit with the Rust compiler. Rust will not let you recursively call something in the compiler like 1400 times. Yeah, I think that's like, so if you had a loop that ran a loop that like it can only go like, you don't have 1400 loops before the compiler says no, that's too much. Like it can't compile, like the compiler can't run. And so
they're basically saying if you need more than 1,400 children manually, like, because this is only for when you're manually writing them out. If you need that many, like, maybe change your strategy, use a spawn iterator or something. Like, you should not be writing that many. This feels like if you're writing this many, it's because you wrote a macro that wrote this. And then they're saying it also applies to the related. So this is like a limitation that I wouldn't have thought normal people would run into, but like apparently it was a thing. And it's cool that like they fixed it, because they were like, hey, we didn't think this would be a problem. Now it's a problem, we fixed it. So decoupling the Bevy public APIs from its rendering API. So in 0.16, Bevy had like the Bevy rendering crate, and so in that crate you would have to it had all like the stuff for doing rendering, like cameras and lights and shadows and images and stuff like that. So all this stuff related to rendering was inside the render crate. But Bevy's gone, hey, like a lot of this stuff can be useful even if you don't care how it's rendered and you want to use some other rendering library than Bevy's built-in rendering library. So they're like, hey, so they're going to split that out, so you can do a whole bunch of stuff that's not in rendering, without like bringing in how Bevy is going to render it. And so they're saying not only does this like let you put your own custom renderer in, which is like what Tiny Glade did, like they built their own renderer on top of Bevy's ECS. They're saying like this will be even easier now, because the actual Bevy renderer is no longer tied to things like the cameras, so you can have a camera and do all your logic with a camera without actually having to dedicate like and commit to using Bevy's renderer. You can then have a different renderer that uses the camera. And also they're saying that like it'll compile faster, because you don't have to wait for the renderer crate to finish compiling to have like a lot of dependencies compiled, because they don't actually rely on the renderer. They rely on like the camera or the light or the shader. So that's all able to be dealt with now, because renderer isn't needing to be compiled in order to have access to these things. Renderer compiles after those things. So it allows for the rendering, it allows for the compiling to happen faster and more in parallel because of that. And they also split off shaders into their own library so that you can have a shader only crate. So what's next is, like what is Bevy doing in the future? So apparently 0.18, we're going to get the next generation scene stuff. So that kind of takes my wind out of my like wanting to make a reflect based scene saver, but you know, we're still going to do it because it's like 3 months away at least. So fun, but like we'll find out. And also who knows if it serializes or not, but so that's like, I think the final roadblock before we'll get an editor. So it'll probably be 0.19 or maybe even 0.18 that we get an editor, but they didn't mention the editor. So it's more likely that it'll be like maybe even 0.20. But it's going to be cool having like a next gen scene stuff. So I think that means that like not only will scenes save like entities and components, it'll also save like resources and assets, and like that kind of stuff can all be like saved as laid out in scenes. And I gotta look into it, but it's not going to. But yeah, so they currently have a working prototype, so it'll be cool and it'll be interesting. And I'll look forward to it. So the fully fledged UI framework. So at the moment, they're Feathers, which is again about like just having the basics, but they're also going to keep expanding on this, adding more widgets and solidifying features like themes and screen rendering support. So lots of stuff to be added to that, like to lower the boilerplate and all that. It's kind of cool. First party entity inspector, again, another step towards adding an editor, is that the currently you use Bevy Inspector EGUI, I believe is what it's called, which is what lets you like look at a entity and be like, hey, this is the like what values are in the component. So it uses reflect to actually look up like the values and can render them to the screen. And so they're saying like they're going to have one first party that lets you like click on an entity, see all the components, see the values of the components and all that without having to use a third party crate. So that's going to be interesting. And there's like so they're saying this will be built with Feathers, so that the idea is that instead of having to have like EGUI and all the context set up, you can just have this feature enabled and then Feathers will render something. Firewheel audio. Yeah. Firewheel audio. So I don't know what Firewheel is. Apparently it's like probably a new framework or something for audio, and they're saying that like there is like a third party crate and they're going to bring it in-house. They basically, Bevy has its built-in audio and they're just going to change to a different framework once it's stable and ready to go. So I mean it'll be interesting to see what it actually is. I could go read it now, but like might as well just wait for the next update because I'm not going to be interacting with it. And then improved examples. So Bevy's trying to come up with more like real examples instead of like a lot of the examples on their website are very much here's the feature, here's the bare minimum to make this feature work, not here's the feature, here's how you would use the feature, because like it's hard to come up with real world examples. So what they're saying is like they want to add more examples that are like, this is an actual use case that you may actually want to implement, rather than here's the code, here's the bare minimum you need to understand it. And the functional implementations are like much more useful as examples than actual like just like here's an example. Because like a lot of the like shader stuff, like when you read it, you're like, yes, that works for rendering a triangle, but like I don't understand like why you're doing it this way outside of to show you that you can. So actual functional examples will be really kind of interesting. Anyway, thank you for making it to the end of the video. It was longer than I expected. Who knows how much is going to get edited out and cut down, but thank you for watching. Like, comment, subscribe to not miss future videos where I'm gonna have to like remake a whole bunch of stuff on my channel because it's really starting to get outdated. And I'll see you in the next one.